Welcome back to Power BI Helpline YouTube channel. Today in this video, we are going to explain what is context transition, importance of calculate function, formula and storage engine of VertiPack and much more. If you are new to this channel, please subscribe and press the bell icon to get notified for all such interesting videos. With that, let's check it out. This is the sales table from Contoso DB. And you can see we have over 10 million records in this table. We know that DAX formulas work on evaluation context, which consist of row context and the filter context. Filter context is basically created due to the result of all direct or indirect filters applied on the table, under which the formula has to be evaluated. And then the DAX expressions perform the expected operation on each row of the resultant table. These rows are called row context. We have to understand that, many times we may get confused about these two contexts, especially when we write expression for calculated columns, as we think there is only row context available, but when we write any iterator function we can understand these contexts in details. Let's understand this with the help of a SUMX function, which is an iterator function. We will first write a DAX measure, using SUMX function, for total cost, which calculates the sum of the multiplication of sales quantity and the unit cost over the sales table. We are now going to see how this measure automatically calculates the total cost for each year in a table visual. We should notice that, in our formula we have never mentioned the year information, but, as I explained, it works on evaluation context, and in this case the filter applied on the table is year. And then our SUMX function calculates the expression for each row of the table which is filtered for that particular year. So how is this happening? Let's check the same formula in a calculated column and see what it calculates. Since this table has over 10 million rows, it may take some time depending on the RAM availability on your computer. Don't worry, we will explain that too in later part of our video, when we will discuss about the performance comparison. We notice that the same formula is working differently in a calculated column, and it is actually computing the total cost over the entire table for each row. Let's look into the formula of calculated column and try to understand row context and the filter context there. We think that there is no filter context, but it is partially true, since we have mentioned here sales table as the first argument of the expression. Actually, the filter context here is entire table without the presence of any filter. But that's not what we expected this formula to calculate. Now we introduce here the concept of context transition. Context transition means converting the row context to an equivalent filter context, and that's what required in calculated column. Then only it will be able to filter that table for each row with converting the same row into an equivalent filter context. The only functions which does this job is called calculate or calculate table. Calculate is a very powerful function. It can modify the available filter context and also it does the job of context transitioning. To apply context transition, we need to wrap the entire expression inside a calculate. And that's it. It will work as expected. You may again get confused as, then how it is working with the measure, where there is no calculate function available. And that's what I wanted to add, that a measure is always wrapped by the calculate function which is not visible. And it means if we call a measure expression, which is just sum of sales, is actually performing sum under the calculate. Let's apply one more filter to the table, which is in year filter, and check the results. As we said that, calculate also modified the existing filters, and that's what it is doing here. It is imposing the year mentioned in the formula, and working as expected. We will also check this in calculated column now. Now with the availability of calculate, there will do the context transitioning, and that also should work properly. Here this already available calculate function is doing the context transition, means it is converting the current row context to the equivalent filter context and then only calculating where the condition satisfies. And if we remove this calculate, then again our expression will calculate wrong results. Let's keep the calculate again at its place. Now let's check the performance aspect of this measure and the calculated column. We will use DAX Studio and evaluate with a summarize column table function by putting one by one the measure and the calculated column expressions. Here we are also going to introduce you the formula engine and the storage engine of the VertiPack. VertiPack is the engine behind our Power BI data models, which runs on columnar database, which is also called, in memory, columnar database. Before running this, you should wait for the query tracing to be started. Here, FE and SE is nothing but the already mentioned formula engine and the storage engine. We notice here that, when we used our measure inside summarize column function, mostly storage engine is being used. In performance optimization techniques, we mostly try to balance the load between formula and the storage engine, and we should mostly give comparatively more load to storage engine, rather than the formula engine, and this measure is doing so. This is the XM SQL query which is being sent to the VertiPack engine, to realize and generate the output. Two things you should keep in mind here is, the query, and the time spent on formula and the storage engine, because we are now going to use our calculated column expression and check the same. This calculated column seems to be even faster than our measure. But how is this possible? We mostly think that measures are faster than calculated columns. You also notice that the XM SQL query here is very small. This is because it has already calculated the iterations and stored it in a physical space and consumed the memory. Let's now check the cost of this calculated column and impact on the total size of the model. The model size is 335.25 megabits. Let's delete this column and check. Now, since we already have the measure, which does not require a physical memory, and only be consuming memory when used. So let's now check the model size after deleting the calculated column. After deleting this column, we notice that 2.5 megabytes has been reduced. And with the presence of measure, which will eventually able to calculate this, and also relying more on storage engine. So the overall summary is that, when we talk about performance, it depends on a lot of things. If we can't afford to increase the model size, as in this case, we are not going to create this calculated column, and rather will use the measure. Thanks for watching. Please subscribe to our channel for more such interesting topics on Power BI.